Hello everybody, we're going to be doing Algebra 1, 2.2.3. And again, just like I did the last couple of videos, I'm going to use the checkup problems within Apex. I'm going to be using the 2.2.2 checkup practice problems as my examples throughout this video. Alright, so I'm going to start with question 1. So what this is, as I kind of get us going or get us written down here, is that this is going to be the same thing that we've been doing. We've been using inverse operations to isolate and solve for variables. Now we're going to be, if I can find my cursor, there we go. And now what we're going to be doing is we're doing the same process, but we are going to be using inequalities instead. Now what's an inequality? Well, instead of having, say, x is equal to a single number, now what we're going to say is x is actually a set of numbers, more than one number. So a quick example is, say I have my monthly bills are like $1,500. So my monthly bills are $1,500. That's what all my bills cost for a month. So how much do I need to make each month to pay my bills? Well, the correct answer would be anything greater than $1,500. So it wouldn't just be $1,500, right? That's not the only, because I don't have to make just enough to pay my bills. I can make more, right? So I'd be able to take that $1,500, I can make $1,800 and have $300 for myself, or $2,000, or whatever it may be, right? There's a whole set of options there. So instead of saying, if I go to the movie, how much does this? If I go to a movie, how much does a ticket cost? Well, it costs $8 or $10. I haven't been to a movie in a very long time, so I could be well off the cost. But it could be whatever that set price is, right? That's one answer. That's not an inequality. Inequality, like I did with my budget example, is just it's a set of options. So inequality just means there's going to be more than one option, more than one answer. Now, I'm going to do it the exact same ways. I'm going to get in here. I'm going to draw my river. All right, so what this is x divided by -4 is less than 16. X divided by -4 is less than 16. Now, what am I solving for? I'm still solving for x. What's on the same side as x? It's that -4. And what is it doing? It's dividing. And how do you get rid of division? Well, we're going to go ahead and multiply. So I multiply both sides by -4. That cancels here, so I'm left with just x. 16 times -4 is going to be a -64. Now, here's the most important things that you will need to keep in the back of your mind as you work on inequalities, is if I divide or I multiply by a negative number, I have to switch the sign. So we have a -4 that we just multiplied. We multiply both sides by the -4. That means I need to take that less than sign and I need to switch it to be greater than. So now my answer is x is greater than -64. So it initially started as a less than, but because we multiplied by a negative number, we had to flip it. And that's where we're at. So multiply or divide by a negative, we have to flip the sign. So let's go and do another example. So we have 3x minus 2 is less than or equal to -20. So this is my less than symbol, and then this is that or equal to part. So less than or equal to -20. So I'm going to go ahead and I'm going to draw my river, and I'm going to ask myself, what am I solving for? I'm solving for x. What's on the same side as x? This all kind of sounds familiar. Well, the 3 and the -2. Well, what's the furthest thing away from the x? I'm going to say it's the -2. And how do you get rid of a -2? How do you get rid of a subtracting by 2? I'm going to go ahead and add. So I add both sides by 2. Now the 3x is less than or equal to -18. All right, cool. What am I solving for? X. What's on the same side as x? The 3. What is it doing? It's multiplying. How do you get rid of multiplication? You divide. So I divide both sides by a positive 3. Now this 18 is negative. The 18 is negative. Should I flip the sign? No, I should not. I should not flip this sign. I'm going to leave it as is because the number that I actually divided by, the 3, was positive. So I'm not worried about the other number, the negative 18. That's irrelevant to what we're talking about. It's only if the number we are multiplying or dividing, this 3, or in this other example, this negative 4, it's only that number that matters. So the 3 was positive, so I keep the sign as is. Let's go to the next example. I have negative 7x minus 10 is greater than 11. All right, so I have negative 7x minus 10 is greater than 11. I just got a dog put in my room, but that's okay. All right, so I have negative 7x minus 10 is greater than 11. I'm going to do the same thing. I'm going to add my river. Go ahead and draw my river in there. And now I'm going to ask myself, what am I solving for? Well, I'm solving for x. What's on the same side as x? Well, it's a negative 7 and a negative 10. What's the furthest thing away from the x? I'm going to say it's a negative 10. So I'm going to add that 10 to both sides. All right, it was a subtracting 10, so I'm going to go ahead and add it. I have a negative 7x is greater than 21. Now what am I solving for? I'm solving for x. What's on the same side as x? The negative 7. What's it doing? Well, it's multiplying. How do you get rid of multiplication? You divide. So I divide both sides by negative 7. All right. So I have x, and then 21 divided by negative 7 is negative 3. Now, it was originally a greater than sign. Do I flip this sign? Yes, I most certainly do. I flipped this sign because the number that I divided by, it was negative. It was a negative 7 that got divided, so yes, I do flip the sign. So now it's x is less than negative 3. Let's see, find another good example here. Let's do question 5, because it adds a little bit fun stuff to it. So we got negative 12x plus 12 less than 4x minus 36. All right, I'm going to draw my river. And now, if you remember back to our last video, when we have x's on both sides of the river, so we have an x on both sides of the equation. All right, when we have that scenario, I need to put them together. I need to combine my like terms. All right. So if you recall, I'm going to ask myself which number is bigger, the 4 or the 12? Well, 12 is bigger than 4, so I'm going to go with the 12. Now, is the 12 positive or negative? Well, it's negative. If it was positive, I would subtract the 4. I would bring that 4 to the 12 if it was positive. But because the 12 is negative and it's the biggest coefficient for x, right? The 12 is bigger than the 4. Because it's the biggest, I'm going to go ahead and move it to the other side because it's negative. So I'm going to add 12x to both sides. That cancels there, and that gives me a 12 equals 16x minus 36. Ooh, I wrote an equal sign, I didn't mean to. Sorry, there we go. Back here. So this was a less than sign. Okay, excellent. Now, what am I solving for? I'm solving for x. What's on the same side as x? Well, it's the 16 and the 36. What's the furthest away? I'm going to say it's the 36. What is it doing? It is subtracting. How do I get rid of subtraction? I'm going to go ahead and I'm going to add. So this was a negative 36. I'm going to go ahead and add 36 to both sides. Now what am I solving for? X. What's on the same side as x? Well, that would be the 16. What's it doing? It's multiplying. How do you get rid of multiplication? You divide. So I divide both sides by 16. And what I'm going to end up with here is, 48 divided by 16 is going to be 3. Is I have 3 is less than x. Now, it's kind of weird that the x is on the right instead of the left, right? So, and that's because we move that negative 12 over, right? And that's okay. So we have 3 is less than x. What I can do is I'm going to rewrite this inequality from right to left. So I have x, And we notice how we'll call it the alligator's mouth is opening up towards the x. So I'm going to make sure it stays that way when I rewrite it. So now it's x is greater than 3. These are two equivalent things. 3 is less than x and x is greater than 3 are the same stuff. That's okay. That's fine. All right. So it is probably better to have the x on the left side. So we just have to flip them. Now what we don't want to do is flip the x and the 3 without changing the sign. We should always make sure that if the alligator is eating the x, the alligator should stay eating the x when we rewrite it. All right. We'll do question 6 just because it has fractions. I'm sure everybody's going to be afraid of fractions. So we have 12 times the quantity 1/2 x minus 1/3 is greater than 8. So the first thing I'm going to do is draw my river. And now I'm looking at it is I have a number outside of a parentheses with nothing in between it. We know that's multiplication. So this is a scenario where we need to distribute. We use our distributive property. So I'm going to distribute the 12 into both of these. So 12 times 1/2 is going to be 6. 12 times 1/3 is going to be 4. What am I solving for? I'm solving for x. What's on the same side as the x? Well, the 6 and the -4. What's the furthest away from the x? Well, we're going to go ahead and say that's the -4. How do you move a -4 to the other side? Well, we're going to go ahead and add 4 to both sides. So we have 6x is greater than 12. Now, what are we solving for? X. What's on the same side as x? The 6. What's that 6 doing? Well, it's multiplying. How do you get rid of multiplication? We divide. Divide both sides by 6, and we're going to get x is greater than 2. And there we go. Okay, so we're going to do question, yeah, we're going to go ahead and do question 9 on that checkup. All right, so, and again, make sure you have that checkup up. If you don't, go ahead and pause the video and pull it up so you can see what I'm working on. The instructions say for questions 9 and 10, the temperature in a city is currently 50 degrees Fahrenheit and is projected to decrease by 4 degrees Fahrenheit every hour during the next several hours. Let h be the number of hours. So they tell us what variable to use. When will the temperature be below 32 degrees? So what they want is the temperature to be below 30 degrees. Well, we know that no matter what, we want 32 to be the bigger number. So whatever this number is on the left side, it needs to be less than 32, right? It needs to be below 32, so it needs to be less than 32. All right, so I kind of set up 1/2 of my inequality here. Just the 32 on the right side with the less than symbol to make sure that the 32 is bigger. What other information do they give us in this problem? Well, they tell us that it's currently 50 degrees. Well, that's probably going to be important, so I'm going to write that 50 degrees down. It's currently 50 degrees. And now, if I'm going to go from 50 to 32, I'm going to have to subtract, right? I'm going to have to get smaller in that subtraction. So I'm going to subtract something. Well, what am I going to subtract? What other information is in the problem? Well, it's telling us that we decrease by 4 degrees every hour, and they told us to use h as hours. So if that phrase 4 degrees every hour, that's screaming multiplication to me. So I'm reading that as multiplication. So we can just write this as 4h. 50 minus 4h is less than 32. All right, and that's question 9. That's all they wanted us to do. So I took the information they gave me, which is they wanted it to be below 32 degrees. So I made 32 the right side of my equation, and I made sure that it got the less than sign, so we got the alligator eating it. All right, because whatever's on the left side has to be smaller than 32. And then it tells me it's currently 50 degrees, so I wrote it. I'm getting smaller, so I have to subtract, so I put my subtraction symbol in. And then the other piece of information is that it decreases by 4 degrees every hour. So we don't know how many hours it's going to take, but I know for each hour, it's going to go down by 4. So I go ahead and make it 4 times h. So if it was 2 hours, it would go down 8 degrees, etc., etc. Now, question 10 wants us to actually solve this. So what are we solving for? We're going to solve for how many hours it's going to take. All right. What's on the same side as the h? Well, the 50 and the -4. What's the furthest away? Well, the 50 is the furthest away. So I'm going to subtract both sides by 50. So I have -4h is less than -18. All right. And now I'm going to go ahead and I'm going to divide. Well, what am I solving for? H. What's on the same side as h? Well, the -4, what's it doing? It's multiplying. How do you get rid of multiplication? I divide. So we're going to divide both sides by -4. And what we get is we get h and we get 4.5. Now, we divided by a negative number. All right, we divided by a negative number. So that means we need to flip the sign. It was a less than, now it's a greater than sign. All right, so we have h is greater than 4.5. Now, what I'm going to ask you is within the context of our problem, what does this answer mean? What it means is that the temperature will drop below 32 degrees after 4.5 hours or more have passed. So in the context of this problem, we were trying to see how long it would take for the temperature to drop below freezing. And we solved it, we got this 4.5. So it's going to take 4.5 hours to be below 32 degrees. And because we know it's an inequality solution set, after 5 hours, it will also be below 32 degrees, after 5.5 and 6, etc. So any number that is going to be greater than 4.5 would drop the temperature to below 32 degrees.